to continue looking at some examples of synthetic division. So let's look at if I have x to the third minus a 6x squared plus 9, and I want to divide this by an x minus 4. We're going to use synthetic division. So if you recall, the first thing that you need to do is you need to get this into an x equals situation. So I'm going to do x minus 4 is equal to a 0. So x is equal to a positive 4. Now that's the number that we're going to put over in our box. Now our degree of this is a 3. So I'm going to start out with this x to the third, and not even looking at my polynomial here, I'm going to have x to the third, x squared, x, and a constant. I'm always going to step these down. I can never skip one. Even though my polynomial may skip one, I cannot skip them whenever I put them down here. I always have to start at my largest one and go down to constant one step at a time. So now what happens whenever I have these that do skip, my coefficient to x to the third is a 1, my coefficient to an x squared is a negative 6, the x is skipped, so I have to put a placeholder of a 0. And these placeholders of zeros are very important to us in the division process. So we can't skip them. It's just like a placeholder where you're talking about a number, 4087. This 0 actually means something. These two numbers are totally different, okay? So this not having an x here means something totally different. So we have to put that 0 in there. Now we're going to do our division, and remember we're going to add our rows together, but remember we're going to multiply this bottom row by this constant of a 4 over here. So our first number is going to come straight down. 1 times 4 is a positive 4. Negative 6 plus 4 gives me a negative 2. Negative 2 times 4 is a negative 8. 0 plus a negative 8 is a negative 8. 4 times negative 8 is a negative 32. 9 plus a negative 32 is a negative 23. I box this off. Here's my remainder. So I started with x to the third. My solution is 1x squared minus a 2x minus 8 plus a negative 23 over x minus 4. When we look at these, this remainder right here, there's a thing called the remainder theorem. And what the remainder theorem tells us is that if I want to know f of 3, I can use synthetic division, and whatever my remainder is, that is what f of 3 is going to equal. So f of 3 equals the remainder when I've done synthetic division with a 3. Okay? For example, if I use this exact same polynomial, so let's say that I'm still using the x to the third minus 6x squared plus 9, and we'll just call this f of x, and I want to find f of negative 2. This negative 2 is my x, so x is equal to a negative 2. Now remember, previously I told you, if this is in an equal situation, I don't need to change this. This number is what is going to come over into my box, because it's already in x equals situation. Then I'm going to bring my coefficients down, starting with an x to the third, x squared, x, and constant. So I have 1, negative 6, 0, and 9. And then I'm going to do the division. So I have a 1. 1 times negative 2 is negative 2. Negative 6 plus a negative 2, remember we're adding. That gives me a negative 8. Negative 2 times a negative 8 will give me a positive 16. 0 times 0 plus a 16 will give me a 16. 16 times a negative 2 will give me a negative 32. 9 plus a negative 32 will give me a negative 23. So I get that have a negative 23. So f of negative 2 is equal to negative 23, which if we were to plug in negative 2 in for these x's, for example, negative 2 to the third minus 6 times negative 2 plus 9, we would get a negative 23. And so when we're looking at this, we should come up with the same number. And so when we plug in this negative 2 into our equation, we get a negative 23 as well. So the remainder theorem is telling us whatever we're wanting to plug in to our x, that's what we're going to get as the remainder here. That is our y value. Think of this. This is our x value. This is our y value. So you can think of it as ordered pairs, x and y, for the remainder theorem. In the next video, we'll do some other examples of synthetic division as well as factoring and so forth.